Hey guys, this tutorial is going to cover how to use delegates in Unreal Engine 5. We'll be covering regular delegates, multicast delegates, and dynamic delegates, which are really useful for providing callbacks to your classes or for implementing callbacks for other classes. A really good example of this is if you've ever made a button using UMG, you've probably had to add a click handler either in Blueprints or in C++, and this is implemented using a delegate. You can actually look at that if we go to button.h. At the top here you can see there's a bunch of delegate declarations, and the first one, F on button clicked event. If I search for that down here, that's the on clicked event for buttons. So you can look at an example here for how one of these things is used and why it might be needed, but generally they're just used whenever you want to call code when something happens. So the first thing we want to do here is declare the delegate that we want to use. So to do that, we first need to include the right header file. So I'm going to include delegates/delegate.h. And now the simplest possible delegate you can declare is declare delegate, and you give it a name, so f some delegate. And this will give you just the simplest possible delegate with no parameters. Now we probably want at least one parameter, so what you can do is do _1 param, and then the next argument becomes the type of that parameter that you want it to be. So this will declare a delegate that takes a single f string and is called fSumDelegate, and it's basically the simplest delegate that you can create. And if I were to step into where these are defined, you'll notice there's a whole bunch of definitions here, and basically they just have every combination of number of parameters here. So we have 1 param, we have 2 params, we have 3 params, and it goes all the way down to 9. So 9 is the maximum that you can use, although I suppose you could make your own definition if you wanted to go higher than that, but 9 is already sort of a lot of parameters, so I wouldn't recommend using too many more than that without just using a struct or something instead. So to use this delegate, again, this is sort of the simplest kind. We can make one as a member variable, so some delegate, and I'm going to call it some delegate1. And then in our CPP file, let's quickly include testclasses.h, and let's make a couple methods so that we can actually do stuff. So we're going to have a init delegates method, and we'll have a execute delegates method. And we'll just implement those in our CPP file real quick. And let me zoom in a little bit as well. Oops, not that much. All right. And quickly implement these methods. All right. So now let's say that we want something to happen when we execute our delegate. So we need to bind code to it. So what you can do is _some delegate1, and there's a bunch of different ways you can bind delegates. So we're going to start with one called BindStatic. And what this will do is bind just a single static method that doesn't have any object that it's attached to. It's just like the declaration says, it's static. So first we need a method that we actually want to bind to. So if I go back to the header file, I can do static void, and we'll call it some static delegate function. And we'll give it a parameter. So now we need to implement that in our CPP class. So we'll go ahead and do that. And we need to tell it what class this is a part of. We don't need the static anymore. And then in order to make it do something, let's just define a log category. And we'll just call it test class sub log all. And now we'll do UE log, and we'll use our test class sub. I didn't actually call it that. And I'm just going to do a warning so it stands out in the logs. And we'll just say some static delegate function, and we'll print out the string that gets passed in as a parameter. So now that we have a function we can call, I can copy the signature And in BindStatic, we just give it the address of that function, and that's all we need to do. And this will bind that method to this delegate. So then in execute delegates, if I do someDelegate1.execute, and I need to give it the string parameter, so we'll call it BindStatic, just so we know which one. And now, when this gets called, it should print out some static delegate function BindStatic. So now, just to show that this is all working, I'm going to go to the player controller, and we'll include that test classes thing. And in begin play, let's do a uTest class. And we'll just call it test class equals new object, uTest class, test class. We want to init the delegates, and then we want to execute them. All right, and we don't care if this goes away after that. That's all we want it to do. So now when I run this, it should go in here, initialize our delegate, and then it should execute. And we expect to see some static delegate function printed to the logs with the parameter that we gave it. So let's build and run. And we'll go ahead and clear the log and hit go. And at the very bottom, you can see it prints out our log message, BindStatic. So we've got that one working, but there's actually a lot of different ways, like I mentioned before, that you can bind a delegate. So we're going to go through each one and show how to hook them all up. So let's go back to our test class, and I'm just going to add a whole bunch more of these sum delegates. So we'll use the same method for all of them. And we'll have 2, 3, 4, 5, 6, 7, 8. And we don't need this last one. And I guess this should technically be private, but it doesn't really matter. So if we go back to the CPP file, the next way that you can bind something is using a lambda. So if you're not familiar with lambdas, they're really cool, and they let you just define functions right on the spot, and you don't need to declare them somewhere else and call out. So it's really good for simple things or things that you're only going to do once, and it really makes more sense in context than somewhere else. So what we're going to do is someDelegate2.BindLambda, and then the argument that this takes is just the lambda function that you want to bind. So lambda functions take a captures list, and I'll explain that in a moment. They take the parameter list, which is an f string, and then they take the function. So then in the function, we're going to do the same thing that some static delegate function did. We're just going to print something out, except we're going to call this lambda. And again, we're printing the parameter that gets passed in. So there's a few different sections to a lambda. I mentioned there's the capture list, there's the parameter list, and there's the main function body. So the function body is what to do when the lambda gets run. The parameter list obviously is the list of parameters that we want, no different than on a regular function. And the capture list is what's fairly unique. And the reason this is here is, let's say that I had a local variable here called hey, and I wanted to use this in my lambda. So let's say I'm going to print out the number as well. I'm going to do comma hey. So this actually won't work, and the reason is when this lambda actually gets executed could be long after this function terminates. So after this whole function init delegates goes out of scope, so is this hey variable. So by the time we get to this UE log, the lambda doesn't actually know where this is, and it's not in its scope. It doesn't even know it exists. So we have to tell it which parameters we want to pass along with the lambda, and that's what the captures list is for. So there's a couple ways to pass it in. We can pass it by reference or by value. If you just type hey here, this is going to pass it by value, and this will work great. And if you wanted to pass something by reference, you could pass the address of it like that. And this is actually a bug if I were to do it now, because like I said, this hey variable goes away and it's out of scope. And if you're familiar with how memory management works in C++, the actual physical address that this hey is at is on what's called the stack, and the stack pointer is reclaimed when this function terminates. So this will actually get clobbered by whatever the next function is that runs when something else gets put back on the stack. So In general, if you're going to pass something by reference, you have to make sure that that reference is going to exist when the function or the lambda gets run. So we'll just pass it by value, and that should work fine. So then similarly, in our execute delegates, we can still do some delegate2.execute, and we'll give it text BindLambda, since that's the method that one used. And we could run and test all these individually, but I'm just going to go through all the different options, and we'll build and run at the end to show that it all works. So the next one is called BindWeakLambda. So we can do some delegate3 BindWeakLambda, and we can do pretty much the same thing as this with one difference. So the difference between BindLambda and BindWeakLambda is weakLambda takes an object, so we'll give it this, and then it takes the lambda. And we can just get rid of this hey variable for now, we don't need it. So the reason why you give it an object is not because you actually need the object in the lambda, although you might, but it tells the delegate what the lifetime of the lambda is. So internally, it keeps a weak pointer to this UObject, and if the UObject goes out of scope or gets deleted, that weak pointer is cleared, and then it will not run this function even if the delegate's executed after that happens. So it's basically a way to tie the lambda to a particular object lifetime. And presumably you would use the object in here, and you could use the captures list to capture this, for example. And then in here I could do this, whatever. But yeah, the main point is that this will not execute the lambda passed in if this object goes out of scope. And it doesn't have to be this. This could be any UObject that you want to tie the lifetime to. So then we'll execute delegate3 as well. Call it BindWeakLambda. So then the fourth kind is some delegate4 dot BindRaw. So if you don't have a UObject, this is how you bind a function to call that isn't on a UObject. So first we need to make one of those. So I'm going to go back to test classes real quick, and we're just going to make a class here called SomeRawClass. Oops. And we'll just give it a method, SomeRawMethod, and likewise we'll give it a parameter. Okay, and then here, let's make one of those new classes. So SomeRawClass, raw class equals new SomeRawClass, whatever. And we're going to intentionally leak that memory because you can't tell me what to do with my memory. So BindRaw SomeRawClass, and we'll give it the method that we put in there. So SomeRawClass, SomeRawMethod. And we need to give it the address of that method. So this will bind SomeRawMethod, and we need to define what that method is. So down here we'll do void SomeRawClass SomeRawMethod and give it the parameter. And then just like all the other functions, we'll just print something out so we know that this one was called and not some other one. So SomeRawMethod and the parameter. So now when SomeDelegate4 is invoked, it should come in here and it should print out this string. So let's execute SomeDelegate4 just like the other ones, and we'll identify it as BindRaw. Great. So the fifth kind that you can use is called BindSharedPointer. So we can do, let's just make a shared pointer first. So if I go back to our header file, we can do tsharedPointer, use some, or uTestClass rather. And we'll just call it some shared pointer. So now in our initDelegates method, let's initialize that. So some shared pointer equals tsharedPointer. Or, ooh, I almost made a mistake actually. So shared pointers can't reference UObjects because they'll get double deleted when the garbage collector runs. So tsharedPointer is only for things that aren't in the garbage collector. So we're actually going to use our SomeRawClass here instead. And I have to forward declare it because it's down here. So we're going to use SomeRawClass here instead of our UObject. So once again, we'll do some shared pointer equals some raw class, and we'll make a new one, new some raw class. This one won't leak because it's in a shared pointer. And now we'll use some delegate 5, and we'll call BindSP, stands for bind shared pointer. And we'll give it some shared pointer, to shared ref. And the reason you need the to shared ref part is because the only difference between a shared pointer and a shared ref is shared refs are guaranteed not to be null. And so when you're binding, you give it the version that's guaranteed not to be null. And we need to give it the same raw method pointer that we gave BindRaw. So this is like a safer version of BindRaw where you can give it a shared pointer to some object so that it does the memory management for you and you don't leak like we're doing right here. So then once again, we're going to execute that delegate. And we'll call it BindSP this time. And for the 6th method, it's actually very similar to shared pointer, except shared pointers can be thread safe as well. So if I go back to the header, I can copy paste this, but I'm going to name it some thread safe shared pointer. And in the template list, to make it thread safe, you do ESP mode thread safe. And you see there's another option for not thread safe, and that's the default. If you don't specify, it'll use that one instead. But basically what this does internally is just the reference count will be thread safe, so you don't get race conditions where you don't actually decrement the reference count internally. And so you can pass this pointer across threads without worrying about the reference count getting messed up. But in any case, there is an overload on delegates for that as well. So you can do some thread safe shared pointer equals, and we can initialize it to the same thing, except we need ESP mode thread safe. And then we can do some delegate 6 dot bind thread safe shared pointer. And we'll give it our some thread safe shared pointer reference, and we'll give it that same raw method to call. So now our thread safe shared pointers raw method will get called. So once again, that's going to go down here. It's the same method, but different way of binding to it. And then the next option is BindUFunction. So we can do some delegate 7.BindUFunction. And this takes a UObject, and it takes the name of a UFunction to call. So we don't have a UFunction yet, so let's make one. So we can copy the method we have. So we can call this some delegate UFunction, and we'll mark it UFunction. And it needs to be a UFunction because it's going to look it up by name. And so that's the reason for that. But anyway, if we go back to some delegate 7 BindUFunction, we can now use the function we just made. So uTest class some delegate UFunction. And so we can bind a UFunction that way. And the last method you can use is called BindUObject. And before I forget, let's execute those last two. So 6 and 7 were thread safe and UFunction. Anyway, the last method is BindUObject. So some delegate 8 BindUObject. And this is similar to the previous one. It needs to take a UObject for the first parameter, and the second parameter is also a UFunction within that UObject. So and actually I messed up. The BindUObject takes a reference to a function. BindUFunction takes the name of the function. So this should have been some delegate UFunction. So these are all the different ways to use just a single delegate. So we have BindStatic, BindLambda, BindWeakLambda, BindRaw, BindSharedPointer, BindThreadSafeSharedPointer, BindUFunction, which takes the name of the UFunction, and BindUObject, which takes a UObject and a function pointer to the UFunction to call. And then we'll call this last delegate 8 as well. BindUObject. And now let's see if this all works. Oh, and actually I have to implement that U function that I made. So we declared it, but we didn't implement it. So let me just do an implementation real quick right here. And it's in uTest class. And we'll print out just like we do for all the other things. And there we go. I believe this should work now. So if I run this, scroll down and look at the log, we have our static, we have BindLambda, we have BindWeakLambda, BindRaw, we have BindSharedPointer, ThreadSafeSharedPointer, UFunction, and UObject. So that's the 8 different ways you can bind to a lambda. And looking back at the code, this is the syntax. So I will post all the code in the description, and you can just copy paste it from there if you'd like. So next I want to move on to the next type of delegate. So what if you wanted a return value on this delegate? So we can go back to test classes, and our previous declaration just had the one parameter, but what we can do is copy paste that, and if we add retval here, we can give it a return value. So I'll just give it a bool. And so the order of the arguments here is the first one is the return value, the second one's the name, and then it's the list of parameters. So a little bit different than the previous one. And like the previous one, you can still have more than one parameter here if you just want to do 2, 3, 4, or whatever. And then for each parameter, you add a type at the end of this list to specify the type of that parameter. So I'm going to go to this delegate 8 here. Or actually, you know what? Let's make a new delegate. So we have to give it a different name. So let's call it some return val delegate. And we'll call it some return val delegate. And all of the binds work exactly the same way. So we're still going to do, let's use just a lambda. Bind lambda once again, and we can even use the same lambda we used up here or something similar to it. And we'll take out the hey, we don't need that. And the main difference between this lambda and the previous one is this one needs to return something. So another thing you can add to lambdas here is an arrow and a type. So if you don't have this, it just assumes that it's void, or it assumes whatever the return value in the lambda is. So I guess I technically don't need it for this, but it does make it a little bit more explicit. But this means that our lambda is going to return a boolean, and we'll just return true. And so if I were to remove this, that would still work because it could correctly infer that it returns bool from this, but we'll leave it just to be a little bit more explicit. And then I can invoke that. So execute return val lambda. And this execute function now is going to return a boolean. So I could say bool return val equals that. And I can log that value as well if we want. So we'll do return val from lambda equals, and we'll just log it as an integer, why not? Return val. And that's how you get return values from lambdas as well. So, or from delegates rather. So that's pretty straightforward. So once again, we can build and run just to test that. All right, and if we run, we'll get all the same logs we did before. But at the end now, we have return val from lambda equals 1, which is true. So that's correct. Okay, so if you remember back at the intro, we looked at button, and button wasn't either one of these two types of delegates. It was what's called a multicast delegate. And multicast just means that you can have more than one binding. So in other words, you can call multiple functions when it gets executed. And so to do that, we're going to still have the same basic syntax here, but instead of declare delegate, it's going to be declare multicast delegate. So we'll add, oops. So declare multicast delegate, and we'll call it some multicast delegate. And just like the other delegates, we can add it to our class down here. So just go below these. We'll do fsum multicast delegate, some multicast delegate. Now to use this one, if I go back to our initDelegates method, it actually has analogs for all of these same bind commands. So we're not going to go through all of them again, but I will list them here. So instead of bind, whatever these things are, it's add instead. So instead of BindStatic, it's AddStatic. Instead of AddLambda, or instead of BindLambda, it's AddLambda. With BindWeakLambda, AddRaw, AddSP, BindThreadSafeSP, AddUFunction, and AddUObject. So just to show how to use these, we'll just use lambdas since they're pretty simple. We don't have to define any more functions, but like I said, you could use any one of these and it's all the same except you have add instead of bind. So we'll start with a lambda. We'll do some multicast delegate.addLambda. And we can even copy the lambda from up here, why not? And we'll get rid of hey, who cares? So we do some multicast add lambda, and we give it a lambda. And the only difference between this and binding is I can add multiple if I want to. So I can do add lambda 1, and I can add a second lambda. So let's call this first lambda and second lambda. And now when I execute multicast delegate, it's going to call both of these. So let's go down here and do that. And when you're doing multicast delegates, you do broadcast instead of execute. And you still need to give it the parameter you want to pass. So we're going to call this multicast delegate. And so this will call every single lambda that's been added to it, or every single, really any delegate that's been added to it. And we'll get our logs in these lambdas. So the other thing you might want to do with these multicast delegates is, now that you have a list of things, you might want to remove stuff from the list. So how do you remove a lambda? So if I copy paste another one of these, I don't have any kind of reference to this, so how do I remove it? Well, it turns out add returns, it's called an fDelegate handle. And this represents the thing that's been added to the list. So you can keep track of this if you need to be able to remove it later. And you can call some multicast delegate.remove, and you just give it that handle and it'll remove it from the list. So now if I were to run this, it's actually only going to call these two lambdas, and this is not going to get printed. And the reason is it's adding it to the list and then it's immediately removing it from the list. So if we build and run this, we can see if that worked. So we'll clear the log and run. And at the bottom, we have second lambda multicast delegate and first lambda multicast delegate. One note about multicast delegates is they are run in reverse order. So if the order matters, add them in the reverse order that you want them to run. But you can see those work just fine. So we go back to our code. And the last thing that we want to cover is dynamic delegates. So the only difference between regular delegates that we've been doing and dynamic delegates is dynamic delegates can be used with blueprints, and they're more restrictive in terms of what you can bind to them. So just like before, we're going to start with declaring one at the top. So declare dynamic delegate. And just like before, you can specify the number of parameters. So we'll do one param, and you got to give it a name. So f some dynamic delegate. And we'll still do a string for the parameter. So we have some dynamic delegate, and we'll add one of those things down here. And we'll go to our CPP file. And in init delegates down here, make some room. So the main method you're going to want to use to bind to a dynamic delegate is going to be BindDynamic. So if we do our some dynamic delegate, BindDynamic, and we can give it a UFunction. So for dynamic delegates, these have to be UObjects and UFunctions. It will not work with any form of raw pointer. So if you have some kind of non-UObject class, you can't use dynamic delegates to call it. Now you could make a UObject class that calls a raw class and you could forward it in that sense. But if you want to have stuff be accessible from blueprints, and thus you're using dynamic delegates, just be aware that they do have to be UObjects and marked UFunction. So if you get some weird linker error, first thing to check is that it's a UFunction in a UObject. But the first parameter it takes is the UObject pointer, and then it takes a reference to the function you want to call. And we do have a UFunction already down here, some delegate UFunction, so we can just use that one. So I'll copy paste that in. And that's how you bind to a dynamic delegate. So I guess we can build and run just to verify that that works. And I didn't give it the reference to the function, so that's why that failed. We'll try again. Oh, and the very last thing that we forgot to do, if I go back to the header file, the declaration for dynamic delegates needs to have the name of the parameters as well. So instead of just fstring, we also need the name. So we'll just call it param name, whatever. And this is because it's linked back to blueprints and it needs to know the function names as well. And I think it's actually called param. But this is a little bit different than regular delegates where you just need the type and you do not need the name. So we'll fix that. Back to our CPP. And we also need to execute this. So down here we'll still do some dynamic delegate dot execute text dynamic delegate. And now we can build and run again. So we can clear the log and run. And at the bottom, some delegate UFunction dynamic delegate did run. And so that's how you use dynamic delegates, or at least the single ones. And the very last thing that we want to do, if I go back to the header file, is dynamic multicast delegates. So this works just as you'd expect. You have dynamic multicast delegate is the declaration, and we'll have some dynamic multicast delegate as the name. And we'll make a delegate declaration in our class, some dynamic multicast delegate. And we'll go back to our init function. And just like for regular multicast delegates, there's add and remove functions. And there's also an AddUniqueDynamic function. So we'll start with just add remove. So just like with binding dynamic delegates, this has to be a UObject and it has to be a function marked UFunction. So do AddDynamic instead of just add. We'll give it this, and we'll give it the same UFunction that we did before. So that's the syntax for adding. And because this is a list, there's a corresponding remove function. So some dynamic multicast delegate dot remove dynamic. And there's no handle in this case. So for the regular multicast delegates, if you want to remove, you need to keep track of the handle. But because we're giving it a UObject and all the functions are named and stored in a table, it actually doesn't need the handle to remove it, so we can just give it the same arguments to remove it as well. And it's also worth noting that you can't call add twice with the same function. If I were to do this 2 times in a row, it's going to crash on this add because it's going to say it's already in there. Because again, it's named and it knows that it's there. It's not just some arbitrary list like with regular multicast delegates. So if I add and remove, and then if I were to add again, this would work. But there's actually another method that you can use. So a lot of times you just want to make sure that something is in the list. You don't want to, you don't have to check to make sure that it's not. And so they have another method called AddUniqueDynamic, which is the same arguments, but you just add unique to the name. So AddUniqueDynamic. And you could do this as much as you wanted. I could do this 10 times, and this is only going to be added once. But if we take a step back and look at what we've done here, we're adding our function, we're removing it, and then we're adding it again. And these are the 3 different methods for unique multicast delegates. So if I call this, so back to our execute method, if I do broadcast, and I give it dynamic multicast, so now it's going to call this function exactly once, because I've added it to the list, removed it, and then added it again. So it should just be one of those in there, and we can build and run. And for the last time, we'll clear the log, we'll run, and if we scroll to the bottom, we have our dynamic multicast printed once as expected. So this has been every single possible way to use delegates and all of the different kinds of delegates. If you like the content, I'd appreciate if you'd like and subscribe, and you'll be notified of future videos. If not, thanks for watching anyway. You can pick up the code in the video description. I'll put it on a gist, so you can copy paste from there and get the implementation. But yeah, this is how delegates work in Unreal Engine 5. Thanks for watching, everyone.